Just get
Hello
set
everyone,
up.
welcome to the TU Berlin Journal Club. Today we have Fabian Neumann, a postdoc from the group, presenting Streamlit, a visualization platform.
Right. I'm just going to start sharing my screen. So this is born out of my course, actually. That was the final lecture where I gave a bit of an outlook. We mostly talked in the course about static visualizations and Streamlit and a combination of, you might know, Plotly or HoloViews. So there's a lot of different frameworks that, other than Matplotlib, that allow you to visualize data interactively and also explore data. And I promised, I think, in the headline of the Journal Club that we're going to build a small dashboard in 50 lines of code. And that's the final product that we're going to produce today. So you see here, this is a Streamlit-based dashboard. It's just like, well, if you think of Matplotlib, is a way to produce plots, and then HoloViews or Plotly are tools to produce this kind of maps or graphics, and then everything you see around this graphic here. So all the dots, the items here we can select, or the sliders and the text, that is based on another library, sort of the dashboarding library, that wraps everything around these interactive plots. So there's a couple of them out there. The most popular and the most, the longest standing Python-based is Plotly Dash. So Plotly is the graphing library, and Dash is sort of the dashboarding library in this ecosystem. And then Streamlit has really been the shooting star. Came out in Corona times and is now closing in on Plotly Dash in terms of popularity. And I think one of the reasons why it is so popular, so I can post this link in the chat. It's a bit of context on what the features of the different dashboard libraries are. One of the main advantages of Streamlit is that it is extremely easy to build and also extremely easy to deploy on the web. So Streamlit offers a service, a free service, where you can deploy all your apps under a public link, as long as they don't consume more than 1 GB of RAM. And it really makes it an attractive solution for someone like you, maybe, who has a paper and you have some supplementary data that is too much to put in the paper, too detailed, to make it available as an explorative dashboard, where everyone can sort of zoom in on every reader can zoom in on their, based on into the results based on their interests. So Streamlit, among these, is definitely the easiest to build, and it's also it's also quite easy to handle overall. So let's go back to this app first of all. So what do we see here? It's I take the data from power plant matching and visualize it on a map. You see here, you probably know this, I can hover all of the information. So the sizes are proportional to the capacities, and then you see here the bar, the coloring indicates the build year. So now what happens is, if I, for example, let's say with hydro, I can use here the slider. Say we're interested in the hydropower plants that are very old, so built between 1900s and 1920. So automatically I have this data filtered, and I can zoom in here. Maybe let's find the oldest one, or one of the oldest one. So here you see some in Norway and one in Heimbach, a run-of-river plant that was built in 1905. in Germany. So you see, automatically, whenever I change something here on the slider, I can also pick the nuclear power plants, which are new ones. Well, sorry, no data to display, but we can go back a few years and then you see sort of the power plants that were built, the nuclear power plants that were built in the last 30 years. Okay, so that's the final product. And we're going to build this from scratch. And for that, I'm going to switch to this tutorial. I can also share this link. No, it's now overlapping with the. So this repository I have opened here. And we're going to build it from scratch. So I'm going to start a new Python file. I'm going to call it temp. And I have a few requirements. So in the terminal, I have here already activated an environment that has basically these three dependencies: Streamlit, Pandas, and Plotly. And I'm going to write a minimal Streamlit dashboard. First thing I have to do is import Streamlit, as the convention is as st. And then I'm going to use do some balloon magic. And this works very similar to shooting up a Jupyter notebook. So I would say in an environment where I've installed Streamlit, I could say Streamlit run, and then our Python file. And that will automatically open a browser and will show some balloons. You already see here some elements of the dashboard. And if I press F5 now, so I reload, it will again shoot up a few balloons. So I can do that every time. And that's actually one of the core concepts of Streamlit, that every time I reload the website or I change an element, it will rerun the whole Python script. And that is an advantage, because other than maybe for other dashboarding libraries, I don't need to implement any listeners, or I don't need to implement the logic, what happens when I change a setting in one of the control boxes. It's really, it runs it from front to back, and really the operation of what happens is really very similar to a Python script, like regular coding. You work with a few if-else blocks to decide what is displayed. But we'll see that in a bit. But it's really important to understand that the core concept is every time I change something, I interact with the dashboard, this Python script will be rerun. You might think that is inefficient, and if you're not careful, that is definitely the case. Imagine we're loading a big data set. We'll do that later. But imagine this read operation takes some time, then it will, and if it has to do that every time, then it's very expensive. and will take it will just the website will lag a lot. But there's some caching solutions so that you can skip this reading step. So
basically, whenever you change the time range for the years, or you change the selection of nuclear versus hydro, it reruns the whole script.
Yes, exactly.
Okay.
You can also implement sort of forms where you sort of delay the rerunning until you have changed multiple parameters. But that's just an additional option. But yes, in principle, every time you interact with the dashboard, it will rerun this. Not if you zoom in or something like that, but on an interactive graphic. But if you change some of the control elements, it will.
So if you want to have a big website that looks into multiple aspects of a problem, you'd kind of want to have Streamlit instances for each aspect rather than having one monolithic Streamlit application. Is that roughly right?
Yes. Yes. Yeah. It depends. There's certainly at some point you want to split it out, but you can also have a single Streamlit app that spans over multiple pages. There's some powerful caching magic that you can do, so it doesn't really have to load all the pages at once.
Okay, thanks.
Okay. So actually, the first thing that I wanted to do now is to import some data, because we want to plot some data, and I'm going to load some data from a URL. I have copied. I'll just copy it over. I'm cheating a little bit, and I'm going to load this. I'm going to load this into memory. And I save the script now. And then I'm going to switch back to the dashboard. And you see nothing yet. But if you look on the top right, it will say, oh, I noticed that the source file changed. I can now choose, do I want to rerun it once? Or generally, whenever I save the Python script, do I want to rerun the script? And it's not a bad idea to do it. So that now, when I say, let's write something, we can say Streamlit title. We can give this dashboard a title, say power plants in Europe. Save the script, and then switch back to the browser. Then we already see the changes we made. You can also add a small warning. Sorry, this page is still under construction, and will show us so like a warning element. But in principle, we could also say it's an error, and then it has a slightly different display. At this point, I'm going to disable the balloons because, well, we don't need them anymore. And what we can do, or maybe one nice thing, you can also use emojis here, like in Discord, and say, oh, we get a small crane here, and just lightens up the display a little bit. So I'm going to cheat again a little bit. So this data frame that we loaded, we can show that in the dashboard directly. We can sort of interact with it a little bit. We can mark certain things. We can view it in full screen mode. Actually, we want some interactive visualization. And for that, in this example, we're going to use Plotly Express. And Plotly Express, go here step by step, has sort of a scatter plot where I can plot the power plants according to their latitudes and longitudes. I can specify a mapbox style, so that is the kind of map that is loaded in the background. You can also skip that first. Then we can say this is very similar to Matplotlib. We can say the color colored by date in. For those of you who've worked with power plant matching, this is a column in the data set, as well as the capacity. And then we can select a zoom level, so how far in should be the map zoomed in. Let's make it 3, and we can say how high this plot should be. And everything else we're going to add step by step. So I've added this code here for this map box, but it's not showing here yet. And I have to tell Streamlit that it should display this graphic. And there's a Plotly chart function. You can say, I want to plot this figure. And I can, one useful argument here is that I want to use the full width of this dashboard. So if I go, let's remove writing the data frame part. So now I have some chart element here, but it's missing sort of some data, and that's probably because I did not say what mapbox style it should be. So now I have this map here. I can move around. I have all the different power plants here muddled together. There's no distinction. It's only colored by the build year. So we have some darker colors for the very new ones and lighter colors for the older ones. And now we want to implement some logic that selects parts of this data frame. And we can implement a thing called, there's an element called a select box, which would take two compulsory arguments. It's one sort of instruction. We can say we want a select box that where the user can select the technology. We can say select a technology. Then the second argument would be a choice of which technologies can the user select, and we can refer them to the fuel types of the power plant matching data, and we only want unique elements. And if I go back now to the dashboard, I have now here this new control element where I can select different technologies, but nothing happens still. And for that, we have to sort of tell, we have to do some filtering like we would normally do in the Python scripts based on what was selected in the select box. And that's actually what the select box would return. It would return the technology that that was selected, and then we can do build a data frame. We say all the power plants where the fuel type equals tech, and then we do not plot the full power plant data frame, but only the filtered data frame. Go back now and select nuclear and see that the chart is changing based on the technology. So that only shows the nuclear, all the nuclear in France. Or if we pick hydrogen, hydropower, you'll see in the Alps and in Norway, for example. So it's I would say, relatively easy to use these select box elements. You can also implement this as a radio. So it's just a different element. We would, well, depending on what style you like. So maybe we want to reorganize this dashboard a little bit, and we want to have all the controls in a sidebar, and we can do that with a with block. You can say we want a sidebar, and everything that should be in the sidebar, we just move it into this block. You can also add another title, say make your selection. We can also write just regular Markdown. So we can also do that multi-lines. So in this block here, we could say, this notebook introduces you to the Streamlit library. You can also, again, use emojis here. And if we save that and go over to the dashboard, then we now have the controls here on the left side. We can also just untoggle the sidebar, and functionality stays all the same. I'm going to add one more control element here, so-called slider object, where you want the user to select a range of commissioning years. And then we can specify, this requires a few more arguments. Say what should be the minimum value, what should be the maximum value, and then we can also pass a tuple what the default selections should be. So let's say the default should be the full range, and we can also say the steps should be in 1 year steps, and we can also add some help, and we'll see how that is shown. Specifies when power plant is built, for example. Okay, again, let's have a look at this intermediary result. So now we have the slider here. We can move things around, and again, nothing is happening, but we have this nice help box here, specifies when the power plant is built. This function, similar to the select box, it returns a tuple, start and end. And we're going to add this to our query here. We say end date in must be bigger than the start, and date in must be more than the end. So we now have three different control items, 3 different filters that we apply to the power plant data frame. Now change the number of power plants based on the range of years. And you notice that it takes a moment to load sometimes. Actually, this is now very fast, surprisingly. But what say the power plant database is not very large, but this reading operation could take some time for larger items. And what one can do is one can wrap this any computationally expensive operation. This could be loading some data, but it could also be some pre-processing computations. So say we had to process this power plants database before we could use it, and that has some expensive calculations. We can also wrap that in a function. Say we wrap that in the function power plants. And this will return just our data frame. And then we just call this function. This changes nothing in the functionality, it only changes the organization. But the nice thing we can now do is we can decorate this function with a caching function of Streamlit. So basically, this will store this the output of this function in some place in where it's easily accessible in memory. I'm not sure if it's kept in memory, but somewhere easily accessible, and Streamlit will notice that it doesn't have to rerun this function when it's called, but can just use what it previously returned when it ran it for the first time. And if at some point we want to clear the cache, there's an option here to do that. But now in principle, I mean, for the small data frame, it's not really noticeable, but it's everything is just a little bit quicker now. So we're already at 46 lines of code. But I'm going to try to break this now. So say I'm going with the nuclear ones, and we know most of the nuclears were built in the 70s or 80s, and definitely not in the 1920s. So if oh, actually that's new. So this used to break in an earlier version of Streamlit.
It's centered on 0, 0.
Yeah, it's centered on 0. It doesn't really make sense, right? So we sort of want to avoid this behavior. We want it to stay centered. Ideally, if there's no data to display, we don't want this map to show at all. And now it's very nice that Streamlit has this attribute that reruns the whole script, so we can check if this data frame is empty. If it's not empty, we want to plot everything. And in the other case, we maybe just want to say no power plant data to display. So now if I go down with this slider, it will just show an error message. Right. What else can we control? Well, we can also so Streamlit is very easy to deploy, but it has fewer configuration options. There's less you can do about the exact layout. But there's a few smaller things that you can do. So right now we don't really use the full width of the dashboard. This could be very nice for an article, right? If you have some markdown text and you have a figure ever so often, then this might be a very nice width to read through it. But maybe if it's more dashboard style without much scrolling, then we want a wider layout. And that's where this interface set page config comes in. We say layout is wide. I'm actually going to do that in one line, so I keep my promise of 50 lines of code. So now we have just a wider layout, and the full width is used.
You also had
Great.
these, when you hover, that it shows the text. Is that something that
this text here, what information is in
it's already there? Ah, okay.
It's already there, and you can also control it. So I can specify some columns of the data frame that I want to show, and then I can pass this to this scatter mapbox function. And now if I hover, I see, let's zoom in a little bit maybe. If I zoom in macOS time, or ESA 2, let's do ESA 2, then we see the efficiency, the date it was built, what kind of technology, what capacity, and what fuel type it is.
Okay, nice. Very nice.
Yeah. And
I have a few awkward questions.
57 lines of code. But
I have a few awkward questions. Should I save them for the end? Or?
No, I'm actually finished for the most. I'm finished. I wanted to show you also how easy it is to just to deploy it on the web. But now's probably a good time to ask questions.
What about lines? Because often what we have is transmission lines. Can you make it plot lines easily, and so that you can hover over the lines and see what the flow and capacity is and that kind of thing?
Yeah, in principle, yes. I didn't do it with Plotly, but if you go to this app I developed for the hydrogen network paper.
So now it's basically the larger data set?
I don't know. It's probably too many people visiting, of course. That's actually interesting that it's not loading.
The scatter mapbox is a pandas specific, pandas tailored function, is it? It seems to know about pandas columns and things.
Yeah, so this is a Plotly Express function. It is designed to work well with pandas data frames.
Okay.
It's so I don't know if some of you have worked already with Plotly, but Plotly can be very verbose and can involve a lot of nested dictionaries to define plots. It's not that convenient to define.
Yeah, I remember, yeah.
But this Plotly Express that sort of offers the most important, a bit like if you have a data frame and call the df.plot function, you get the most important matplotlib settings, but you cannot do everything that you could otherwise do with a matplotlib plot. And in this way, the Plotly Express is very, very similar. Okay, now it's loaded. So yes, so I used the HV plot for it. So not only another library, and there you can integrate it with NetworkX to show network capacities as well. So I could now.
How many lines of code did that take?
We can look it up. So this is definitely a little bit longer, but this whole 650 lines of code, but it's also, I mean, it's a very long format. So it's plotting of the network. So well, it's 150 lines roughly of code for this view here, where you can select also where the onshore wind, where some technologies are built.
And you can also hover on the lines and see what the capacity is. And this hover,
yes,
okay,
yes, you can hover what the capacity is, what regions they connect. It's also useful for debugging somehow, which how the regions are called. And yeah, you can see
that would be very useful to be able to do this inside the IPython, to be able to call network.streamlit and have in the output then this, so you can then debug things. Is it possible to embed it inside the Jupyter Notebook?
Streamlit itself, I don't think so, but the bokeh plot, the HoloViews plot itself, that's designed to be in. It's originally thought just a Jupyter Notebook visualization.
But do we have that functionality in PipeSet at the moment?
We have this iPlot function, but we could just.
This iPlot's terrible. I coded that like 5 years ago, and it's just probably it's probably just the wrong thing, right?
No, I thought about it, but I just didn't do it.
Okay,
but basically, yeah, we could implement a successor. I think this HoloViews libraries. So plotting networks with Plotly is a bit inefficient, I think. But the HoloView is just generally very, very efficient and requires very little code.
Yeah, it was a nightmare to get the lines in the Plotly. I think all the boilerplate there is to do with the lines, and if it's doing the lines nicely here, then we should just do it.
Yeah, and that's also what makes this iPlot function very inefficient, is because it adds it adds a plot for every line. Yeah. No, we can think of that. It's very useful. Generally, hoverable information on a complicated network is much easier than.
It's quite hard to debug PipeSet if you've got network flows involved. Like you have to kind of try and guess or you have to kind of do a lot of boilerplate code to see which lines are connected to the bus and then see what the flows are or whatever. It's always been bad, and this looks like it would basically address it. So the other question goes a bit in the same direction. If I wanted to embed Streamlit inside this model.energy scenarios, how easy is it to embed it inside other websites?
So
use case would be that I select several scenarios and it automatically builds me the Streamlit for those 5 scenarios.
Yeah. So yeah, there's different ways. So I mean, the way you would deploy it on a server is also just through an Nginx server that that exposes a port. So I think you could probably, if you have model.energy, you could sort of forward to this other. Once the job is done, you forward to this other website, then have a link back. Probably the least intrusive for the code you already have.
Yeah.
In principle, it's also possible to have to have this solve job now, form and etc. inside the Streamlit Streamlit dashboard, and then connect the Redis queue basically in this script. You could, for example, in the sidebar, you could say you put your Redis queue job here, and then it would just wait until it finishes the job to display all the other information.
Okay,
don't know if that's the better solution, but you can, yeah. In the end, it's just a JavaScript website with.
Yeah, so it should be possible to embed it somehow. I'm sure it must be. I think it'd be a bit cleaner to embed it rather than having to re-implement the other features inside it.
And for your network, the Hydrogen network, there you mainly use hvplot, right? Even for the data frames, or is there no data frames or bar plots?
Yeah, so that's all of that is hvplot, except for the Sankeys. The Sankeys are Plotly.
Okay.
Because well, there's path dependencies, and not always every tool does everything you want. hvplot also has Sankey plot functionality, but can't do cycles. It's very important for us here. So something like this here, where you have some of the electricity that goes into a battery, and then it goes, part of that goes into the transport, but some of it goes back to electricity. It's just not possible with hvplot.
Oh, very nice.
I mean, basically, we should basically integrate this with the scenario management. I mean, not just for the modeled energy scenarios, but also for our local instances when we have lots of scenarios. So you can do all this analysis as soon as your job is solved. You don't have to wait for someone to build a website for it.
Yeah, SnakeMake does something very similar. They basically produce an HTML website that displays sort of the statistics and the order of the jobs were run. Basically, you can open a browser and explore how the job was run after it finished. And in that sense, you could also, if we were very eager to implement like a basic, we computed this pipes at URSec network. Here's how you can explore it. Not with the intent of being published, but just looking at have automated Sankey diagrams, for example.
That'd be very useful. I mean, because mostly what we're doing is we're rerunning things and we want to compare it to some previous version to see what the influence is of what we've changed. I mean, this is the usual work pattern, and it'd be very useful to automate that. So we can select two scenarios we want to compare and see what the major differences are, for example.
Yeah, exactly.
Oh, it's very cool. Thanks for presenting that Fabian. So basically, with the website deployment, you have Nginx, which is listening to a port, and you can then forward that to any URL.
Yeah.
Okay.
Yes, and that's the complicated route actually. You can also just go to use the Streamlit Cloud app. The documentation, by the way, is also very nice. So you have all this API reference of all the different elements you can add. You can write LaTeX. You can display tables, and you also have this very different options, input widgets, like download buttons or variety of select tools, sliders. You can also do calendar inputs or upload files. So you could write a dashboard where you upload a pipes.netcf file, something like that. So documentation is very nice as well. And you can go to share.streamlit.io. And basically, I put this dashboard in a public GitHub repository that really just has this Python script. That's basically what we've been building. So 56 lines. It has this requirements.txt file for pip. And actually, these two files are the only things you really need to have in the GitHub repository to deploy it. You can have sort of a config tunnel for Streamlit, where you can define what the primary color or the background color and so on should be. But this is really optional. So the only things you need are the Python script and the requirements.txt. If you use something else than Streamlit. And then you basically just reference this repository, say which branch it should run from, what the main file should be. You can store some secrets if you need it, but in principle, you can then just hit deploy. And it will appear. This was now relatively quick because I already set this up. But in principle, it maybe takes a minute or two. What it will do is, whenever you push to the repository, it will update this page. It will install the environment and then basically do the same command I did locally before here, streamlit run temp, and it will just display it. And that's it. So 2-minute introduction to deploying an explorable web app.
This is super, super nice. Is it also possible to change then the name of the deployed website? So it's changing the URL?
Yeah, you can choose this this part of the URL.
Yeah. Okay.
Yeah. So I'm done.
Great, thanks a lot, Fabian. Are there any questions for Fabian about the thing? I mean, my main thing is let's do more of it everywhere.
I'm really thinking about. I mean, I spent like a couple of hours trying to get that report from in the SnakeMake workflow for Pipes.sec going, but it didn't work out in the way I wanted it. And we might think about introducing that into the main workflow of Pipes.eur then in the future. Just produce some basic results based on one configuration, and later we could probably extend it to comparing different configurations of the output. But perhaps starting just with a simple HTML output from the Streamlit app done within the workflow.
Yep, totally. And my idea would be basically this interface from model.energy, where you can just basically select scenarios and then compare them. So this should basically be available, that you can just fire it up for your results folder and then just choose any scenarios and then compare them. So here you can just select. I can share my screen. So here you can just select any scenarios that you want, and then it'll compare them and display all the results about them. We basically do this not in my hand-coded D3.js, but in the nice interactive version that Fabian made. That makes sense.
Yeah, definitely.
And basically here you'd be able to select. So this is done by names and ID, but here we'd have run name and then scenario string, basically.
How is debugging in the code when there is an error in your Streamlit Python script? Does it?
It will display the error in
Nice.
in the dashboard.
Yeah, I mean that's good. That's good.
And it will also display it in the terminal.
Yeah. Awesome. Very impressive.
I think just maybe as a wrap-up note, the nice thing about it is that it's very easy to deploy and it's not a lot of work. So it's really in the realm of just if you have adding it to your paper and having a few extra results to display. I think people generally enjoy interactive dashboards, I think.
I would propose to upload this video to YouTube, if that's okay with you, Fabian, and then you can share it on social media or something, because I think other people would find it useful.
Okay.
Do we have everyone's...
all the people doing the advertisement for me.
Do we have everyone's consent who spoke to you put it onto YouTube? Okay, cool. Then I'm going to stop recording now.